Okay, hello everyone and welcome. I am Dr. Rawad Isamuddin Farah. I am a civil engineering specialist. I have a PhD in civil engineering. So today we'll be starting short course in concrete mix design, and we will be starting by cement and aggregate, which are the components will be used to produce concrete. So for cement, there is one major or very important terminology that we are hearing, which is called the setting time or setting of cement. The setting of cement, there are two setting time. First one is the initial setting time, and the second one is the final setting time. For the initial setting time, what is it? The initial setting time is the beginning of noticeable stiffening in the cement paste, which is known as the initial setting time, and the final hardening process, which is responsible for its strength, which is known as final setting time. The time from the addition of the water to the initial and final setting are known as the setting times. Setting time is affected by cement composition and the fineness of the cement, rate of hydration, and the ambient temperature. According to ASTM C150, which prescribes a minimum initial setting time of 60 minutes, which is for Portland cement, and according to the same standard, the maximum final setting time of Portland cement is 10 hours. But for the initial setting time and the final setting time, there is one important terminology that we have to know, which they call it consistency of the for the cement, which is the amount of water divided by the amount of the cement multiplied by 100. It will be in percentage, which they call it the consistency of the cement. So we can see through this video.
In this video, we will cover the normal consistency of hydraulic cement experiment. In other words, we will measure the amount of water which is needed for the cement to react completely with water. To perform this experiment, you need the following: a mixer, a VCAT apparatus, a conical ring, a balance, a 650 gram of hydraulic cement, and water. For start, measure a randomly assumed amount of water. 170 gram of water is a good initial assumption. After that, put the cement in the mixing bowl. Then add the water to the cement and wait for 30 seconds, allowing the cement to absorb the water. Fix the bowl in its place and run the mixer on the slowest speed for 30 seconds. Stop the mixer for 15 seconds. Again, run the mixer on the medium speed for 1 minute. Turn off the mixer. Then quickly start to form a ball from the cement paste with the gloved hands. After that, toss the ball between your hands for 6 times. Place the ball in the conical ring. Using a straight edge, remove all the excess paste on top of the ring. Place the paste under the 10 mm VCAT rod. Adjust the rod until it becomes in contact with the paste surface. Then set the indicator on 0. Release the rod. The rod will penetrate the paste. The normal consistency is obtained when the penetration is equal to 10 mm after 30 seconds of forming the ball paste. So, you have to repeat the experiment with different amount of water till you meet this object. And by that, we were able to determine the normal consistency. In this video, we will cover setting time of hydraulic cement by VCAT needle. In other words, the time that cement need to react or hydrate completely with water. In order to perform this test, you need the following: the VCAT apparatus, two needles, thick and thin one, a mixer, a timer, a 650 gram of cement, and a defined amount of water, which has been determined by the normal consistency test, which we had covered in a previous video. Click here or on the link in the description box to see the video. First, put the cement in the mixing bowl. Then add the water to the cement. Run your timer at the exact time you have added the water to the cement. You need to prepare the cement paste as we have done in the normal consistency video. Leave your paste for 30 minutes. Place the thin needle on the VCAT apparatus. Set the indicator on 0. Adjust the needle until it becomes in contact with the base surface. Release the needle. The needle will penetrate the paste. Repeat this operation every 15 minutes until a 25 mm or less of penetration is obtained. The time between the initial contact of cement and water and the penetration of 25 mm is the initial time of setting. Then, place the thick needle on the VCAT apparatus. Set the indicator on 0. Adjust the needle until it becomes in contact with the base surface. Release the needle. The needle will penetrate the paste. Repeat this operation every 15 minutes until the needle fails to penetrate the paste. The time between the initial contact of cement and water and the fail of thick needle to penetrate the paste is the final time of setting. And by that, we were able to determine the setting time of hydraulic cement by VCAT needle.
All right, so let us continue. We have seen the consistency test and we have seen also initial and final setting time test. Okay, here is the apparatus which we call it VCAT apparatus and the needles which they are used to conduct the test. Now we'll be talking about ordinary Portland cement. Generally, the ordinary Portland cement used for general construction work when special properties are not required. So normally we can use it in reinforced concrete building, bridges, pavement, sidewalks, when the soil conditions are normal, so they are not harsh and they have chemicals that they will affect the building or the construction will be done. And sometimes also you have sulfate hazards. When we have sulfate hazards, we are not using normal or ordinary Portland cement. Generally, ordinary Portland cement can be found in two different strengths, 42.5, which is 42.5 megapascal, which is the strength for 28 days, and 52.5, which is 52.5 megapascal at 28 days. This is the strength. Now let us talk about aggregates. In general, the aggregates occupy at least 3/4 of volume of the concrete. Quality is especially important. It is cheaper than cement, but put into the mix as much as possible according to the mix design. It gives higher volume stability and better durability than cement based alone. There is a general classification of the aggregate. We will see uh, in terms of production, in terms of size, and so on. But let us start by production according to production methods. We can see natural aggregates, which are those are taken from native deposits without any change in their natural states during production, except crushing or grading or washing. And the example for that is the sand and gravel, crushed stone, lime rock. There is another type which is called byproduct aggregates. This one, which is compromised, blast furnace slag and cinders, fly ash, etc. Cinders are the residual of coal and wood or wood after burning. Also, we can talk about processed aggregate, which is a heat treated, expanded materials with lightweight characteristics, and those are the examples for the processed aggregate. And also colored aggregate, which is like glass, ceramic, or manufactured marble for decorative and architectural purposes. Then now we will talk about the petrological characteristics. In general, there are three categories. We can put the rocks, we can call it igneous rocks, sedimentary rocks, and metamorphic rocks. So for the igneous rocks, which is coming from solidification of molten lava, forms igneous rock. And those are the example like granite, basalt, and quartz. Sedimentary rock, they are obtained by deposition of weathered and transported pre-existing rocks. Examples like sandstone, limestone, and shell. And this type of sedimentary rock, if they are hard and dense, so they are okay. If not, they will be high absorption capacity, which is for the water, we mean, which give unsatisfactory results, which we will know later. And metamorphic rock, which are formed at depths under high heat and pressure by the alteration or changing of either igneous rocks or sedimentary rock, as an example, which is well known the marble. Again, if they are hard and dense, they are okay. If laminated, those are undesirable. Here we can see an example of the igneous rock, like the basalt. Here is the bombise. Here are some examples of the sedimentary rocks. Then we will be talking about now for the aggregate. Now we are talking about in terms of particle size. So in general, we are dividing the aggregate into two main categories. Fine aggregate, which we can call it also sand. This one we can say for the particles that passes through 4.75 millimeter sieve and retained on 0.075 millimeter sieve size. For the coarse aggregate, which is the gravel, those are for the particles that they are retained on 4.75 millimeter sieve. This is one for general information, the cell size and clay size, and those one they are depending for the sizes on the standards that we are using. Then according to the unit weight or their unit weight, if we are talking about normal weight aggregate like sand and gravel and crushed stone, they have this range of unit weight. For lightweight aggregate like slag and slate and other light stones, they are under this range of unit weight. And this type of aggregate will be used for concrete, such as for insulation purposes. And then heavyweight aggregate, hematite, barite, magnetite, and steel and iron punchings. The range of the unit weight will be between this range. Now, let us talk about the strengths of aggregate. The strengths of the aggregate or the crushing strengths of aggregate cannot be tested directly. So they are indirect tests that can inform us about the crushing strengths of the aggregate. One of the methods is called crushing value test, or other mechanical properties of the aggregate. They are tests that we can be done to get those one. So for example, like impact value of aggregate measures the toughness of particles by impact. Here is the aggregate impact value test, and here is the machine. You will place the aggregate here, have hammer, and you have counter. I don't want to go to details of this test, but if you need more information, you can search on that. And the operation of aggregates measures the resistance of aggregates against wearing. It is a very important property of concrete in roads and in floor surfaces subjected to heavy traffic. The most frequently used test method is the Los Angeles abrasion test. This is the Los Angeles abrasion test apparatus. And here are the references are